EUMETSAT OSISAF, Météo France.
Hi everyone. I'm going to present briefly OSISAF work. So a quick update on what has been done last year and what is going to be done soon or in progress. This is a contribution from other OSISAF partners, including some here, Jacob, Slinar, and Gorm. Sorry. Okay, so yeah, and of course the whole OSISAF team is contributing behind the scene. So OSISAF, if you don't know very quickly, OSISAF is the satellite application facility for ocean and sea ice. Its main goal is to deliver product of the sea surface derived from mostly from meteorological satellite. And the product developed in OSISAF are sea surface temperature, sea ice parameter, sorry. So surface emissivity, temperature, drift, and so on, wind speed and direction, and radiative fluxes, the short wave and long wave downwelling radiation. OSISAF deliver product in near real time and also create some climate data record or data record in some cases. And so OSISAF, I should have started by that, but there are 5 partners. OSISAF is led by Météo France, and it's a consortium with the Meteorological Institute from Denmark, Norway, and the Netherlands, and also IFREMER. So we, in particular, develop global sea surface temperature product. And one of the tasks is, of course, to ensure continuity of the production for existing product and update the production when necessary, when there is a new satellite. So the existing production is for METOP B and C, NOAA 20 at the moment, soon to be NOAA 21, GHRSST26, so which has changed in the last in April, I think, it became GHRSST19, and METEOSAT in 0-degree position and also in over the Indian Ocean. And recently we had the launch in 2022 of MTG I1, which was declared operational in December 2024. And so we had done a lot of work in the past years on this new instrument. And as you may know, there was a problem shortly after launch when the onboard calibration system failed. So at the moment, there is an intercalibration using YASI. Sorry, there is a... there is also the instrument is affected by Earth traylight, which has a quite large impact in the infrared channel, where there are large contrasts over the scene observed, so close to the coast, close to the cloud, and so on. EUMETSAT has developed a very effective Earth traylight correction, which is applied now. There is unfortunately still a remaining striping effect, which you can see on the figure on the top right. This is on the 12.3 micrometer channel. I think you can see it. You have some horizontal stripe, which are due to faulty detectors. There is a solution to that, and EUMETSAT is currently working on that. So this will hopefully disappear in the future. Nevertheless, the global statistics compared to drifting buoy measurement are very satisfactory and do not show any problem. The product developed by OSIsoft should be declared pre-operational by the end of this month. It is pre-operational because there is still ongoing work, in particular to correct this striping, but also on our side to adjust some of the parameters of the processing chain. So it is pre-operational and should be declared hopefully operational by the end of the year or early 2026. Another task we are starting now is reprocessing of the whole Severi archive. So from the beginning in 2024 until now. And this should be done using the bias-aware optimal estimation, and in particular with the help of ON and University of Reading. Regarding high latitude sea surface temperature and ice surface temperature, so on the near real-time production, there is level 2 and level 3 SST and IST from GHRSST and VIRS sensors. This was mentioned by Jacob just before me, so I don't need to go into these details. There is an upcoming change to introduce cloud probability in addition to the classical threshold-based cloud mask. So regarding high latitude, there is also activities on reprocessing, also mentioned by Jacob very briefly. So there are plans to deliver a new version of the ASTI product and so on, with a new improvement, of course. This should be ready in 2026. And okay. And now I come to some other activity we are doing currently. So on the EUMETSAT side, most of the OSIsoft products have been added to a visualization platform, which is called the Scene Tool. You can visualize very easily most of the product, SST product, of course. There is an ongoing harmonization effort between OSIsoft and EUMETSAT. And the idea is to change the definition of the SST we are producing, or at least provide another additional SST. Currently, we are delivering a subskin SST, what we call a subskin SST, which is an SST calibrated with drifting buoys. And we would like to homogenize our production with EUMETSAT, providing a skin SST as well, by implementing a cool skin model and diurnal variability model. So this is an ongoing effort in the framework on the CIFORMAS project, which will have after implication for OSIsoft product. There is also an effort at EUMETSAT to generate a comprehensive and quality control data set of in situ measurement, which also after will be used in the OSIsoft product validation. And one thing I want to mention is that we are currently preparing the next phase of the OSIsoft product, so the CDOP5, which will begin in 2027, and we are just right now beginning to prepare it. So if you have any wishes or a question or whatever, this is the right time to come and talk to one of us. And I think that's it. Thank you very much.
Thank you, Stefan. Any questions? Okay, so we move on. Okay, so I'm going to give an overview of EUMETSAT sea surface temperature activities. I'll give a little bit of an overview of both EUMETSAT and Copernicus missions, launches, and operational status. I'll go through our SST activities, talk a little bit about studies and projects, and also talk about third-party sea surface temperature data. Our primary objective is on operational meteorological satellites, but we also have objectives on operational oceanography and also climate activities. There's a whole range of so this is our mission planning for the long term. Our main mandatory programs are the GEOs and the LEOs, the MSGs and the MTGs, and the EUMETSAT polar system, so the METOPS. We also have all the Copernicus activities, which with the current operational ones are Sentinel-3, but looking forwards towards particularly SIMA and Sentinel-3 next generation optical. So upcoming launches. So next month we have the launch for MTG, the first sounding GEO satellite with IRS as the main instrument for sea surface temperature. We also have the next generation of the METOP, so METOP-D, in a launch coming up in August. So it's a busy time. That has METIMAGE and YASI-NG. Next year, there'll be the second MTG. So Stefan sort of mentioned about the first one, the FCI. So that's coming up next year as well. And we also have the Sentinel-3C launch, which is at the moment scheduled for October 2026. Sentinel-3D will then follow in 2028. And the first SIMA-A launch is planned for the end of 2029. So this diagram just gives an overview of both sea surface temperature and sea ice surface temperature. So this combines both EUMETSAT activities and the EUMETSAT AUSSI-SAF activities. So as Stefan sort of set the scene just now, the AUSSI-SAF produce the EUMETSAT level 2, level 3 products from our mandatory programs. Whereas for the Copernicus activities for sea surface temperature, we do these in-house at EUMETSAT. So this diagram kind of gives sort of an idea of where we are now. The green ones are the current operational missions, and the blue ones are those under implementation, so sort of kind of nearly there. And the red ones are the ones that are progressing and under development for the next few years. So some are at EUMETSAT, some are at the AUSSI-SAF, and some are shared between EUMETSAT and the AUSSI-SAF. A couple of last year's highlights. So our reference sea and sea ice surface temperature continue for the IST for the sea ice surface temperature. So these are pre-operational products. They've been available since April 2024 on Wikio, and we're preparing for the operational deployment, which is currently planned for January 2026. So we are continually welcoming feedback on those products, and Igor's going to tell more all about those later. The other key highlight Stefan already just mentioned is on the FCI SST. So for MTG-I1, the mission was declared operational in December 2024, and the AUSSI-SAF SST products are due to be pre-operational by this month. So I won't go through the AUSSI-SAF again because Stefan's just explained it, but yeah, so these produce the EUMETSAT level 2 and level 3 products for our mandatory programs. So Copernicus reference sea surface temperature. So Sentinel-3 SLSTR provides reference quality satellite sea surface temperature, and we're also developing the sea ice surface temperature operations at the moment. So Igor's going to give a presentation tomorrow on the complete status of that with all the details, but just a couple of highlights. So in 2026, we will deploy operationally the new collection 4. So this will have the SST and the sea ice surface temperature in there. It'll include the SST depth as well as the SST skin, and it'll have the new IST. Also in around 2026, we'll also start producing the offline or ICDR SST from SLSTR and AVHR. That will be available soon from Wikio. And the idea is that we introduce the ICDR for SLSTR as a non-time critical product in the kind of time frame 28, 29. So that will be incorporated into our operations and ground segment at that time. But in the meantime, they will be available from Wikio. So EUMETSAT will concentrate on the SLSTR ICDR, and the OSISAF will process the AVHR ICDR. So this is all in planning. We're also preparing for the Sentinel-3 Next Generation Optical ASLSTR with ESA. Launch is approximately 2034. So that will provide a continuity of reference mission with improvements in spatial and spectral resolution and channels. And we'll hear from Simon Proud and Paolo Cipollini later in this week. We also have sea surface temperatures from YASI. So these have been available in L2P since 2014. We're working on a new version with machine learning, and that's under preparation. We're also starting to think about preparations for GHRSST L2P from IRS and from YASI NG as well. So these are all in planning, and you can go to the EUMETSAT data information for more information on that. So the Copernicus Imaging Microwave Radiometer, we're also preparing for this mission together with ESA. It's the EU Copernicus Expansion Programme. So the launch of the first one is planned for around 2029. It's going to be a wide swath conically scanning multi-frequency microwave radiometer. So EUMETSAT will focus on the global atmospheric and ocean products, which will include sea surface temperature. For the SST, it'll have a spatial resolution of about 15 kilometers. And Robin is going to give a presentation on that from EUMETSAT on Thursday. A little bit about our science studies and CalVal framework. So we have a project you may have heard about called CipherMast. So this has been running for a few years now, and it's actually the GHRSST project office has been part of this project as well. But there's various outputs coming out of that project, including a product development plan for SLSTR, the IST Cloud Mask Validation Report, intercomparison of SLSTR and OSISAF products, developing a new CalVal tool for visualization and validation, and evolution of multi-matchup data sets. So Igor's going to give a poster on a lot of these aspects this week as well, so please take a look out for that. Towards harmonization of consistent SST and IST products. So you've heard a little bit about this so far. So this is something we're working on together with the OSISAF and within the CipherMast projects. So the idea is that for all our EUMETSAT and Copernicus SST products, we'll produce provide both skin SST and depth SST, and also work on consistency of high latitude products. We'll also think about the CalVal framework and performance, and longer term consider harmonization through BOE frameworks. So within this, we're working on a shared community diurnal variability model, and this is also in coordination with some other partners as well. So the International GHRSST Project Office, I already mentioned this morning. So this is hosted by DMI. It's part of the Copernicus CipherMast project. The project is coming to an end next year, so we're preparing a new ITT for the GPO for the next 5 years. So the main message here is just that EUMETSAT and Copernicus are committed to supporting the continuation of the GHRSST Project Office activities. We also work on fiducial reference measurements for SST, and our Copernicus Trusted project now has been going since 2018. So this was to establish a sustainable fiducial reference measurements for Copernicus satellite SST and IST. So far, we've deployed over 190 SST drifting buoys with 2 sensors. The key part here is the calibration per sensor, the metadata access, and the traceability diagrams. And we also work with the European Meteorology Network on these and the WMO DBCP. Started a few years ago was the development towards a sea ice surface temperature buoy development. So DMI have been our main partner with this, and we now have a prototype available. Gorm has more information on this one if you're interested. And calibration and testing of that continue as we look forward to operations in the next few years. And finally, I just wanted to mention that we do have third-party data agreements for sea surface temperature. These are provided through our EUMETSAT services. There is more information via the user portal, but if you're interested, I just put the list of data agreements that we have there. So in summary, we continue to produce the Copernicus reference Sentinel-3 SLSTR sea surface temperature. We're doing evolutions to include IST in 2026, and pre-operational versions are already available. The Sentinel-3C launch is due for October 2026, and the EUMETSAT Aussie staff continue to produce SST products from our other missions. We're working on harmonization of all EUMETSAT Copernicus SST missions, and our science studies continue, including evolutions to the Calval framework and continuation of fiducial reference measurements. Okay, thank you. Any questions?
I have a quick question here for you, Anne. This is Ed, if I may.
Hi, go ahead.
Yeah, on that new ISC product that uses the machine learning, what does that machine learning do? Is it something with cloud masking or a little gap filling, or how are you using machine learning for that product?
I'll have to get back to you on that one. That's our hyperspectral team has been working on that. So basically, they're doing a new algorithm, and it will include some cloud masking in that as well.
I see. Yeah. Thank you.
Excuse me. How long ocean surface wind vector are available?
Sorry, can you repeat the question?
How long ocean surface wind vectors are available in the past?
I'm sorry, I couldn't get the question. From which mission?
For the level 4 wind vector product, no?
So, well, we have ocean vector winds being produced as part of the SIMA mission. So that will be kind of a joint retrieval of many different parameters. So it'll be SST, salinity, vector winds, etc. But we also have surface vector winds available from our METOP satellites. So these go back now to 2006, I think. Okay, thank you. So we now move on to the next presentation, which is Ed Armstrong from NASA JPL.
All right. Can I go ahead and share my screen here? And there we go. I think you can see my screen fine, right? And let me just get this out of the way here. Does it want to go out of the way? So I apologize from the onset that I did not put this actually in slide format. I put my report in the template format in the Word doc from the that I got from the project, and I guess I got a little bit lazy to put it in some slides. So I apologize for that, but I'll be able to address all the salient points just talking to the text right here. I think I can do this in a pretty efficient manner. So yeah, I'm Ed Armstrong from the NASA Jet Propulsion Laboratory. And I'm really speaking on behalf of the entire PODAC project. That's the Physical Oceanography DAC that's responsible for the distribution of the oceanographic sea surface temperature products from the NASA portfolio. And, you know, we're a 20+ member strong team of scientists and engineers who support the data curation of these many data sets. And so the Physical Oceanography DAC, I just looked a few days ago, we currently have 100 and even 100 public risk data sets in the NASA Earth Data Cloud. And we have been in the cloud, as I've reported now for several years. So this report just kind of summarizes where we are right now and where we're going to. So we have released in the last 14 months 3 new data sets. I have them listed there. That's the EWSG2. That's the name for the GOES-15 from the NAVO. And also some VIIRS products from our collaborators in the NOAA OSPO the VIIRS NOAA 20 and NOAA 21 level 2P products. And we're actually in the process of onboarding some new products, including a very exciting level 4 sport product. So that's also produced by a group in NASA at the University of Huntsville. And that's a new approach for doing level 4. It's actually going to be a very novel contribution to the GHRSST catalog, because it's going to be 6 hourly level 4 global SST views encapsulated in a single granule for one day. And then we're working with the NOAA folks to get the GOES 19 back in the pipeline. All right, so I'll present some also here in this shortly here, some user statistics, but I also wanted to point out that we've been heavily invested in researching in the field of cloud data virtualization. So using these emerging technologies like Chunk, Virtualizar, and IceChunk. And I will have a presentation this Thursday in the Science, Data, and Computing session on this subject. And also, we've been collaborating with somebody from Development Seed, Amy Arciaucas, who actually has a poster on the IceChunk technology. And we've been learning a lot via our collaborations with her. And I would encourage you to go see her proposal this afternoon, because this is a rare opportunity to really engage an expert in this technology who's really working on the cutting edge and doing some very exciting things that she will report with GHRSST products using this IceChunk data virtualization technologies. Okay, so GHRSST science team members, myself and Jorge, we've been actively supporting a number of different GHRSST initiatives, including the intercomparison, the CDAF, and the GDS task team, as well as continuing with the linkages to the CEOS SSTVC and the COAST VC. You'll hear in those reports here just coming up shortly. There's been a number of exciting initiatives and collaborations there, and I think really important to the future of GHRSST and high resolution thermal remote sensing. We've also made contributions to the Data Coordination Committee for the UN Decade of the Ocean. All right, so we're a data producer for the GHRSST MODIS Aqua and Terra and SNPP VIIRS L2P. That's a collaboration with the University of Miami and the NASA Ocean Biology Processing Group. And actually, in the last few months, we did a trial run of producing GHRSST L2P for the VIIRS on N20. And so we actually, tested that, and we had a version running in the user acceptance testing, and everything looked good. But there were some concerns about the SST in the existing N20 product that needed to be addressed before we were comfortable in providing a public release for this this particular data set. So we're just kind of waiting for those problems to be resolved, and then turn on the pipe that we have for the MODIS to include the VIIRS on N20 and eventually N21 as well. All right. Of course, the Muir Level 4 SST is one of our premier products, and still an extremely popular product that we distribute from the PODAC. It's found in a number of different tools as the base layer in the SOTO by Worldview, for example, and it's just used in a number of applications by different users around the world. And so we have made some progress in kind of designing and setting the foundation to operate the level 4 Muir SST in the cloud, because at the PODAC and at JP as a whole, there's a thrust to remove all the on-premise hardware. So the PODAC actually is ingesting and storing all the data in the cloud, and now we're moving all our production systems for these different products. We already have the MODIS Aqua Terra L2P and SNPP VIIRS running in the cloud, and the next step is to get the Muir Level 4 SST in the cloud. And I'll say a few more of that here shortly here. Okay, so I just wanted to present a few kind of user metrics slides that we always do here. So the first chart shows the PODAC monthly cloud users of specifically those 100 GHRSST data sets. The next one shows the monthly cloud volume, and they're really just, it's steady as she goes. We have hundreds of users on the monthly, unique users on monthly timescales. I don't really see any trends in any of these figures, and we're still supporting up to like 40 terabytes monthly on average as a volume of GHRSST data that we're distributing to the community. And the number of files, again, is in the hundreds of thousands. So yeah, the take-home message here is that, GRIST is now a very mature project, has a mature user base, and there's, still tremendous impact, but based on the number of monthly file downloads and the number of unique users for our many products. Okay, so now talking a little bit more about what's going to go on with MUIR, and we've actually won a proposal that was selected in June. We actually haven't started the work yet, but the idea of this proposal is to take the MUIR science data system, which is running on some on-premise hardware at JPL, and to migrate it to the AW cloud. And so I have a little figure here of what this architecture looks like. It's pretty straightforward, but we're going to be leveraging a number of different AWS services, including AWS Batch, which is a service designed for efficiently doing submitting and monitoring jobs, large scale computing jobs, as well as taking advantage of things like the S3 storage, and doing the whole kind of orchestration of all these different services with an AWS service called the step functions. So this is what we intend to implement in the cloud, and we're going to kick off this work actually next week. And it's a one-year effort. So hopefully the goal is by the time we meet next year that the MUIR processing system will be fully functional and independently running in the AWS cloud. So, okay, that's it for MUIR. I think the rest of my report here is just a list of the different GRIST products we specifically produce and maintain at the PODAC. I've mentioned them all before. And as I mentioned also that we've updated our processing code for the virs on N20, but we haven't implemented yet. And I think I'll just summarize by saying that the exciting work that we're doing right now, and that also I'm going to be reporting on, is this cloud data virtualization technology that we've actually applied now to a number of GRIST level 3 and level 4 data sets. And come see my talk on Thursday and Amy's poster to learn a little bit more about this. But this is really the next step forward in our mind of improving the user experience and scientific computing for data sets that are in the cloud. So the entire GRIST portfolio that NASA manages is already in the cloud, and we're seeing data going into the cloud in other areas too, in Wikio in Europe, and really all over the world. So the more we learn and implement this technology, I think the stronger and the more we can grow our user base. It's really quite an exciting time. All right, I think I'll just stop right there and see if there's any questions. And again, I apologize for this little ad hoc method of doing this presentation. So,
thank you, Ed. There are a couple of questions.
All right, I don't see the chat or anything like that, so maybe somebody go ahead, please.
Yeah, hi, Ed. This is Peter Cornellan. When you present your statistics for use of the data that's in the cloud, do you separate out the data that are used within the cloud, or just the data that are moved out of the cloud?
No, I wasn't. I guess I wasn't 100% clear, but all our GRIST data products are all 100% in the cloud. So these are the cloud statistics that I'm reporting. There's no on-premise distribution of any PODAC data, GRIST or otherwise.
I think I understand what you're saying, but I'm not sure you answered the question I had. So if I were to use the data in the cloud but not pull it out, how do you count that?
I don't have a good answer for you. We do. Let me think about that for a second here. Yeah, I understand what you're doing. You're a user that goes fires up an EC2 and goes in the cloud and access the products.
Yeah, I just used 4 million.
For one thing, we capture your EDL login when you're logging in and accessing data in the cloud. So regardless, if you do that login from an EC2 in the cloud or if you're running from a notebook locally, so I think the answer is that we are capturing that in-cloud experience, and it is being reported here.
You might want to separate those two out, because one of the reasons for putting it in the cloud was to make the data near processing.
Right, exactly. Yeah, so that's a good point. I should have included that. I have seen some figures from somewhere in the PODAC, somebody showing that. And off the top of my head, I want to say, yeah, those users that are actually going to the cloud and doing compute in the cloud is growing, but it's still a minority compared to those people that are pulling the data locally and say, you know, operating it on their laptop once they have the data locally. You know how much of a minority? I want to say maybe it's like 25-75 or something like that, or 1/3, 2/3, something like that.
Thanks.
Yeah. If I find something better, maybe I'll share it with you, Peter, during the meeting here.
Okay, thanks, Ed.
All right, thank you. I'm sorry I'm not there in person with you guys. Oh, can I mention one thing here, Anne, before we move on? I forgot to mention, yeah, this is kind of a rapidly evolving landscape. But unfortunately, the first budget proposals that we've received so far are of concern to a number of missions that are important to GHRSST. One of them is that the SPG mission has been proposed to be canceled 100%, and that would be a big loss to high-resolution coastal thermal remote sensing. And the other one is that the MODIS Aqua and Terra are going to be on an accelerated decommission schedule, and so are not expected to be have any data from them after October. So I'm sorry to be the conveyor of that bad news, but that's where things stand as of right now. Thank you.
Okay, thanks, Ed. So we move to the next presentation. So we have Pallavi Govekar from Bureau of Meteorology.
Yeah. Okay. So I'm happy to report on our contribution to GHRSST from Bureau of Meteorology. All of our most of the level 2 to level 4 products are funded with Integrated Marine Observation System, that is IMOS. Last year we have been working on SST. Helen got retired in March. And then Chris moved to data assimilation group in the Bureau. So he is partially supporting SST now, and with the ban of use of contractors, we lost CAT also. So at the moment, it's mostly satellite SST with me and in situ SST with Haipeng. It's not moving. So we produce couple of level 2, level 3, and level 3 U, C, and S from NOAA 9 to NOAA 19. We have reprocessed back to 1992 for most of the satellite sensors. We have Himawari 8 and Himawari 9 reprocessed from 2015. We do produce multi-sensors, level 3S, that is composition of different polar orbiters, and then geopolar multi-sensor is the composition of Himawari with polar orbiters. For the in situ SST, we do process ship, Argo, drifted voids, and SOPs moorings. All these data are available in GTS on AODM. AODM is Australian Ocean Data Network. And most of these in situ data are being used for calibration validation purpose and into ingestion of level 4 SSTs. So last year, we mostly worked on getting our SES bias right for Himawari 9. We have reprocessed for Himawari 9 from 1 October 22 to 30th of September 24 now. We are using University of Reading SST CCI version 3 code for processing Himawari 9. And then we use those Himawari 9 in geopolar multisensor. This geopolar multisensor we are further using for developing our heat stress, marine heat stress and marine heat wave monitoring tools. For the level 4, the main work this time we did is transitioning to new supercomputer. So that includes replacing old SMS scheduler system with Silk scheduler. And then early this month, it went operational, and now METOP-C is included in RAMSA-GAMSA. That is now METOP-C GAC AVHRR L2P data is using to ingest METOP-C in these level 4 products. All these products are again available with PODAC and AODM. At the Bureau, we use it for numerical weather prediction and seasonal forecasting and climate services. It is part of GIMP. And then RAMSA is being used for weather prediction, monitoring marine heat waves, and in NOAA star arms. The right-hand side panel showing the comparison of GAMSA with other CMC and OSTIA and GIMP. Since we start ingesting VIAs in GAMSA, we do have similar statistics with other level 4 products. Bureau has replaced the legacy weekly, monthly 1 degree SST blend level 4 with GAMSA for all our climate services. And the climatology also replaced. So before we use Reynolds climatology, which was calculated for 1961 to 1990. So now instead we are using ISA SST CCI that is calculated over 91 to 2020. For the ship SST, currently 27 IMOS ships are reporting quality control real-time SST to GTS. These are also going to NOAA STAR, IQAM, and AODM. Currently, 9 vessels report real-time QCID SST to GTS, 3 in buffer format, and more scheduled to begin very soon. SST depth that is ingested into climate data base, that is ICORS, and SST analysis, and also it's being used for satellite SST validation. So in the right panel, you can see IMOS ships are much accurate than other ships. This is plot from IQAM. And the upper panel is showing all the ship tracks that are available from February 2008 to May 2025. ISR SST scan from RV Investigator. So in 2014, CSRO installed first ISR on RV Investigator. 1,217 days reprocess data is available from ISR 5D010. It is in IMOS format and available on AODN thread server. There was failure from ISR 5D010. Again, ISR 5EE016 also had problem, and we are waiting for its return to USH for repair. CSRO received new ISR 5EE020 in 25, early 2025, and then that became operational on RV Investigator from this March. These are being used for validation of satellite SST. So Himawari 8 and Sentinel data was validated with ISA and having published that with remote sensing, cool skin effect investigated, and also for the model evaluation it was used before. So plans for upcoming year, we want to put our Himawari 9 processing in operations, and then along with geopolar multi-sensor, we want to run in operations. So by end of this financial year, next financial year, we are aiming to do that. Bureau has provided a REAP temp that was heat stress monitoring metrics from with use of level 3 SST product for the Great Barrier Reef region. We are expanding that to whole of the Australian coast, and I will be talking about that in my presentation on Wednesday. So all of the Australian coast will be covered, and SST anomaly, degree heating dates count, mean positive summer anomaly, marine heat wave categories, and marine cold spell categories will be provided daily using level 3S product. We want to include NOAA 21 and METOPSY. Actually, NOAA 18 we were processing in our operational system that we had to stop last week with decommissioning of NOAA 18, and then so we have stopped processing NOAA 18 and put METOPSY, and today morning only the change was approved with the operational system. So next couple of days we'll be having METOPSY in operations. For IMOS ship SST, 2-3 more newly recruited IMOS vessels equipped with ship AWS and SPE 48. Haipeng is working on generating buffer message for all IMOS vessels, and he had generated that his image working on buffer with ChatGPT, and for some reason ChatGPT thinks it's too complicated. It has given him 6 cups of coffee to do this thing there. So yeah, and then Haipeng is also with CSRO trying to reprocess ISR's skin SST data from 2025 voyages. And I think that's it from me. Okay.
Thank you, Pallavi. Any questions? Okay, Jorge, I see you've got your hand up. Do you have a question or a comment?
Oh, I'm sorry. This is with regard to the comment that Ed made, about SPG. Yeah. The one thing I want to just make sure that people understand is that the budget situation is still dynamic. So even though that doesn't look good for future missions like SPG, it's not settled yet. The one positive thing is that EcoStress was funded to continue under the current budget proposal. So anyway, I just wanted to kind of just clarify that, because I don't so that one message doesn't kind of get out before the final budget proposals are decided. Thank you.
Thank you, Jorge. Okay. Thank you, Pallavi. We move to the next presentation. So now we have Niraj Agarwal from ISRO.
Yeah. Good afternoon. I'm Neeraj Agarwal, and I'll be representing ISRO, and I'll be sharing the agency report, what work has been done so far. So, it's not moving. So, currently, there are two satellites in the geostationary orbit, that's INSAT 3D-R, which was launched in 2017, and INSAT 3D-S, which was launched in February 2024, that is last year. So they are operational. And apart from that, OceanSat 3 was launched in 2022, which had a scatterometer, an ocean color monitor, and an SST monitor. So the products of scatterometer and the ocean color monitor are operational. However, the SSTM operations have been stopped due to some in-orbit anomaly. However, we are in process of launching OceanSat 3A, which is going to be a repeat mission for OceanSat 3, and it will be also having a sea surface temperature monitor. So that is expected to be launched in December 2025. As far as the policy point of view, the government of India actually unleashed the reforms in space domain in 2020, and it invited the participation of the non-governmental entities to carry out the end-to-end activities in the space domain and its applications. So this policy is now implemented, and it has now encouraged the private partners also to participate in the applications. So these are the missions that ISRO has launched. So of late, INSAT 3D, which was operational till last year, is now stopped functioning. The one in green, and INSAT 3D-R is operational. INSAT 3D-S was launched last year, 2024. So it has been moved at the same location where INSAT 3D was there. And then coming up will be GHRSST, which is going to be another, geostationary satellite. And then in the LEO orbit, there are several missions which are currently operational. The OceanSat 3, then US-07, that's the microsat, and OceanSat 3A, as I mentioned, it's going to come, will be having sea surface temperature monitor, and CNES ISRO joint mission Trishna, you must be aware. So that is also going to be launched sometimes in 2026. Now, just this slide is showing the basically the evaluation of the data that we are getting from INSAT 3DS, which was launched last year. So INSAT 3DS, so we have developed the two retrieval algorithm. One is the nonlinear regression-based algorithm, and the other one is the 1D variational-based algorithm. So those products from both these algorithms are operationally available on the ISRO portal, and which I'll be showing later. And there were some issues in 3D-R as far as the calibration is concerned. So now the entire data has been reprocessed for the INSAT 3D-R for last 8 years data. So I'll be having a presentation on 19 June demonstrating this data set. As far as the INSAT 3DS is concerned, so we are in process of computing the regression coefficients from the matchup data that we have already prepared. So I have a poster over here, which you are invited to look at, which is showing the performance of the INSAT 3DS data so far, whatever we have got. So these are the basically the accuracies denoted here, and this I'm showing one image of representative image of a particular time and also the daily average of the sea surface temperature obtained from INSAT 3DS. So basically now we have these two geostationary satellites which are giving data at every 15-minute interval, operating together. And so far the initial results are promising from INSAT 3DS. However, there are certain issues which we are looking at, specifically in the northwestern Arabian Sea, when we are comparing it with the standard GHRSST products. However, with IQAM data, we have seen that the accuracy of around 0.7 to 0.8 Kelvin. And this is the OceanSat 3. So as I mentioned, the other products from the scatterometer and the ocean color monitor, they are operationally available on the ISRO portals. SSTM, however, unfortunately could not perform. So there will be a follow-on mission which is going to come up in December 2025. And this is the Trishna mission, which is going to give a very high resolution sea surface temperature and then coastal regions, and we are looking forward to it. And it will going to give a very unique opportunity to look into the very fine scale features of the coastal sea surface temperature. I'm showing here one such example where the thermal discharge from the nuclear site and the southern state of India. So the thermal discharge can be easily seen in this eco-stress data, which is not seen in the coarse resolution product. So from Trishna, we will be able to see such kind of signatures in the future. And similarly, this is an example where the coral lagoons also also cause a thermal gradient around them, so which is not seen in this the standard data sets that are available. So Trishna will also give some insight into these temperature gradients, and also the temperature gradients caused by the river plumes. So other missions that are going to come in the near future from ISRO side is the INSAT 4th generation satellite. So that is basically will be having an advanced imager, 16 bands, and also this will be having a faster scanning for nowcasting applications. So this slide is slightly, a month old. So now they have, updated it. The full disk image every 15 minutes, and Indian landmass every 12 minutes. 5 minutes, and mesoscale imagery every 2 minutes. So sorry about this. Actually, this is slightly old. And then this will be also having a lightning mapper and a hyperspectral infrared sounder. Amongst the low Earth orbiting satellite, so we'll be looking towards the microwave temperature and humidity sounder in the low inclination orbit. That will be coming on the OceanSat 3A as well. And then we are also in discussion to launch full range from 6 to 89 gigahertz microwave radiometer. So that will also be useful for the 6 gigahertz channel for retrieving the sea surface temperature. And then scatterometer, ISRO is going to continue these missions, and also the hyperspectral infrared sounder is also going to come in the near future. So all these things are in discussion, and as I mentioned, so like the policy is ISRO's policy is like the user now based on user demand. So the users have basically Indian users have basically requested such kind of sensors. So these are the specifications are under discussion. And this is the portal, the meteorological and ocean data, satellite data archival center, so mostec.gov.in, where you can find the data from these satellites, which I have shown. So these data sets are available there, and it has the number of users now are increasing. There are so many Indian as well as international users that are logging into the MOSDEC site and getting the data. And we are also continuing with the, using these satellite data sets. We are demonstrating several applications, developing several applications, and then transferring these technologies to the operational institutions for so that these applications are benefiting the common man. So these are some of the applications that we are doing, right from the PFZ advisories to marine heat waves, and also the climate change kind of a study. Thank you.
Questions? Okay, we move on to the next presentation. And we have online Shakila Baker-Yeboah from NOAA.
Yes, will you be advancing the slides or should I share my screen?
Yes, Shakila, you should share your screen as we agreed upon earlier.
Okay. All right. Had some computer problems this morning. Let's see if I can get that working. Just a minute. Okay, is it working?
Yes.
Yep, it's fine. Go ahead.
Okay, I'll go ahead. Hello, everyone. I'm Shakila, and I will talk to you briefly about the NOAA NASA's SSTs that we have in operations. And our team of people who work with our SSTs include Ken Casey with our data stewardship lead, Andy Harris with Veronica on our blended SSTs and physical retrievals, Ali and Veronica on our AXPO SSTs, Paul Chang on our Amster 2 SSTs, and Wyman/Patrick Hogan on our OI SSTs. And there's a team of people working with all of us in general. So the NOAA NASA's operational SSTs, as I mentioned here, we have various teams that work on those. We have our National Centers for Environmental Information, which is our NCEI team. And we have our NASA Center for Satellite Applications and Research, which is our STAR team. A lot of our algorithms come out of that end. And we have our OSPO operational satellites and product operations that handles the operational aspects of the SSTs. So we all work together with our SSTs. And I will say that we are undergoing a lot of reorganization and adjustments at this stage. And I'm happy to be here with you online at this point to give you a short overview. So NOAA NASDAQ continues to adjust to a changing environment, technology, and ongoing changes. And our mission for science, service, and data stewardship is ongoing. Satellite operations and data distribution, we handle a lot of that. Evolving relationships with our users and commercial sector, our national and international partners. So we most certainly value our user input and feedback. So please feel free to reach out if you have any questions. NOAA provides the near real-time, delayed time SSTs from NOAA. We have a combination of things that we provide 24/7 in near real-time, and then we also have reprocessed products that are provided as well. The Office of Satellite Products Operation focuses on the near real-time SSTs, and many user groups are included in that as we distribute data out to them for extra distribution as well. The user estimates, I just wanted to note here, I think maybe we noted last time, we're undergoing various reviews of our SSTs in general, from our level 2s to our level 4s. And oftentimes we have to stress the importance of all of our SSTs. And of course, we have our Geopolar Blended, which is a level 4 product that uses a lot of the level 2 components. And it is one of the most broadly used NOAA SSTs that we have. In addition to that, we have our OI SST, our AXPO SSTs, as well as smaller users for our Amster SST components. So the SSTs at NOAA, we have quite a few of them. And again, we are continuously evaluating those as we continue to move forward. Product production, as I mentioned before, is being transitioned into the NESDIS Common Cloud Framework, which is an Amazon cloud environment, and we have had a lot of work done in that avenue, but we have a lot more work to go. And I just want to say that we work in conjunction with our Office of Common Services that has pulled a team together to help work with us on our satellite product distribution and productions, and it is a much larger team now as we move forward and try to migrate all of our algorithms as well as our data distribution into this NESDIS Common Cloud Framework. And we have some of our SSTs that have been migrated over already, and we have quite a few to go. So this is just an illustration here of our agency work in progress, again, with the cloud component as we look to migrate different observations into the cloud and regarding the algorithms as well as the product production, and maintaining sort of a management of what's happening with those satellite data as we continue to move forward. That is, all of our logs, all of our software ideally is going to be on that side and sort of managed for us. And so it's a process, most certainly a process that's been moving forward for quite a while, and we're not there yet. We've had a lot of bumps in the road, and I'm hopeful that we will get there with all of our SSTs, hopefully by the end of next year. So our AXPO Advanced Clear Sky Processor for Oceans components, Ali has been working really hard on trying to get those products up to date. As you know, we have quite a few of those in the cloud right now, the Himmerori, as well as the SNPPs, and NOAA 20, NOAA 21, VIIRS SSTs. We also have the METOPS A, B, and C for the AXO products in the cloud. And we migrated our level 3 supercollated PM and AM components just last year in July. I think that was just right around the time we had the meeting. It was almost done, but not quite done. We have also expecting our GOES 18, 19 components to be migrated. We have had a ton of delays with those. And I'm, disappointed to say that those aren't migrated just yet, but we're expecting to get those completed by the turn of next year, hopefully February, March, as a lot of components that we've been working on will be coming to an end. So we're at a push to get those components in as well. We have the GOES 19 satellite. We migrated that. It moves to GOES East this year, just in April. So we had our operational transition on April 3rd for the transition to GOES East. And we are now hoping to get the funding in place for those products next year. So we are anticipating that Ali will be able to work on those next year for the GOES 19 component. And we are again expecting the AXPO 3.0 coming up in March of 2026. So those are one of the last ones we'll have migrated into the NCCF as we continue to move forward with the SSTs. The agency's level 2 geopolar blended SSTs here, Andy has been working on those with us to get those migrated into the cloud. And I will say we've had a lot of hiccups on this end here. There are a lot of components that we have to migrate into the cloud, and the cloud services simply does not support us with the MATLAB, and that has been an issue for us. And so we have been working really hard to get all of those transitioned over, and I'm excited to say that we will finally be getting those over, hopefully by the end of this year, if not in early next year. So I've put a date here of March 2026 because the timeline has shifted so much with other components that are taking place in the transition of our products into this NOAA Common Cloud Framework. We have a whole team of people, again, that work with us on the various products. We have the Coral Reef Watch products that are, we have just a ton of users for the Coral Reef Watch components that come from the geopolar blended SSTs. And as you recall, the pie diagram, the blended SSTs feed a lot of our applications. And we have a lot of Coral Reef Watch users as well. And we have been working on a comparison paper on coral reefs. We have additional work to do on that. It has had a bit of a setback, and we're hoping to get it back on track sometime later this year. So the Coral Reef Watch products, there's also a talk that's going to be presented today at the meeting on corals and SSTs. So we have a lot of work going on in the agency in reviewing our SSTs that go into our Coral Reef Watch products. The physical retrieval, we have that as well, the level 2s. Those are in process as well as being migrated into the cloud system. We are hoping again to get additional funding for our third generation products with the OSPO Advanced Clear Sky Processor with OLI in place for NTG OSPO 2026. This is a work to be done. And then we have our AMSR-2. We just recently migrated our Global Change Observation Mission Water Advanced Microwave Scanning Radiometer software processing package into the cloud. This is just like a week ago that we migrated it towards the end of May, and the final products are on the PDA as of June 4th, precisely. So we are looking forward to getting those into the archive as well. So the distribution is primarily through the PDA, as many of you know, who pull data from the operational system. And we are working to get that migrated into the cloud. We're anticipating the PDA will be migrated sometime, hopefully, by the end of next year. That is the time slot, and so we're hoping that that works well. We also have the S3 bucket NCCF access in progress. We've just recently implemented the open data access for all NOAA data such that we can then put more data into the cloud and make it more available. So that is a work in progress. Some of the products I will say are in our NOAA open data dissemination component. So we try to make the data available to users in as many ways as possible. And it's a case by case, particularly for pulling data from the cloud system. Right now, we are still migrating our PDA, and we're hoping that that migration system will be ready by the end of next year. We also have the archive service through NCEI, and again, products continue to be migrated into the NCCF, and NCEI has an archive system that is connected to the cloud. The NOD system that I mentioned earlier is not directly connected to our NCCF system. It is a separate system, the NODs, and the one that we are working on with the NCCF is related to the NCEI archive system. So NCEI is our primary archive. Timelines are being revisited. The first cloud work that went into the archive work that went into the cloud was in late 2024, and feel free to reach out and ask any questions. Ken is our lead on those components. So, but in time, all of our GHRSST LTSRF data archived in NCEI will be available through the NCCF Cloud Archive. So that's a long-term stewardship reanalysis facility. We have all of our GHRSST related products in that system, and we're working really hard to make sure we keep getting them all in there updated and moving forward. And Ken Casey, again, is our lead point of contact on that. This was the GeoXO data distribution. Ken she's working on that as well. And again, we're trying to get the data available via the cloud or internet using a ComSat broadcast. There's a lot of work going on there as well. OSPO manages all of those comm systems. And we have Tomrin Kevins, who is our lead on all of these various satellites that we have going on with data distribution and our ground processing systems as well. All of that is still going on. So we have our LTS RF update here, our long-term stewardship and analysis facility with NCEI. Again, we are still trying to maintain all of the effort that goes into that. Wyman was our lead on that, and he's working now. Patrick Hogan is working collaboratively with him this year, transitioning that effort over. Ken Casey, John Ralph, as well as Yongshin Zhang and Sherry Phillips on helping to provide our GHRSST archive products to users and always working to maintain those archive services. So we are trying to make sure we keep our data sets updated in the GHRSST system as well. The LTSRF, Total Archive Holdings, similar to last year, we haven't had a lot of changes. We are working on getting the AMSTER added to that as well. I think last year we had a lot of work going with the L3S components that came out and getting those into the system. And we had some issues with Hurricane Helen, and there's just been a lot that's been addressed. So I will say John and the team have been doing a lot of work to try to get the data into the system consistently and fill the gaps in as well. So there's a lot of ongoing effort to keep this moving forward. Prasenjit, I think he was working on this last year. He said that he's done a little bit more on this decadal trends using the CCI SSTs with applications. So he continues to work on some of our SST applications moving forward for different components as well. He has quite a few systems in place that he's working on. He's working on some frontal stuff as well, and I think he'll report out on that in one of the task teams as well. So there's a lot of agency application work in place as well. Here we have some improving understanding of uncertainties in SSTs. Again, this is a group that's working on improving our Coral SSTs. Blake Spady will be giving a talk with that, working collaboratively with Andy and Stephanie Deuce and Scott Heron. And the ongoing agency work for the Celestia is still moving forward. Andy is still working with Gary and Ann Carroll on this effort. It's an ongoing effort, and again, we have been adjusting to various changes, trying to move things forward. The bias corrections are still in progress, and the work is ongoing at this stage. And then lastly here, we have this NOAA-centric activity to leverage our GHRSST activities and infrastructure. And the idea here is to sort of look at all of our SSTs and try to reduce the number of SSTs that we're producing, but to produce them consistently from level 1 all the way through level 3, such that in our level 4 products will have level 2 inputs into them as well. And that is, some work has been done on that with Sonju Lee and Andy Harris, and they'll be talking about that at the meeting as well. Nearing the end here, the file names, we're still working on our file names, maintaining our GHRSST structure. I will say the AMSTER2 files at one point had a bit of a glitch in it in the past. We had on the NDE system there was some errors in the file name, and we've gotten that corrected with the GDS version included in that. And we will continue to try to keep our GHRSST file name specifications in place as we continue to work on our SSTs. And at some point, we're going to drop off the OSPO NCEI star part of the file name and go with a full NOAA. And as we continue to make adjustments this year, some of those things have been on hold, but I'm hopeful that we will get there before the next GHRSST meeting. So in summary, the NOAA NESDIS continues to adjust to changes in information technology to support our satellite operations and data distribution, and our evolving relationships with users in the commercial sector as our national and international partners also evolve. And we're working on the NOAA-centric activities for our SSTs as we continue to reevaluate them, moving forward to the enterprise approach with SSTs in our NESDIS Common Cloud Framework with our archive, as well as our product production and product distribution. So please feel free to reach out if you have any questions, and we will get back to you. That's all I have. Thank you very much.
Thank you, Shakila. Any questions? Okay, so I don't see any. Thank you again, Shakila. We're going to move to a coffee break now, I think. So we come back in 20 minutes.